and welcome to 1.3 multiplication as part of the pre-algebra lecture series. So we're going to get into it. So what is multiplication? Well, we could go ahead and take the number line interpretation just like we did last time with addition. So we'll have 0, 1, 2, 3, 4, ... So let's say we have some number which is going to be 2 times some other number which will also be 2, let's say. So what we're going to have is 2 times 2. What does this mean? 2 times 2 simply means we're going to take 2 and add it to 2 twice. So this is going to mean 2 plus 2. So 2 times 2 is equal to 2 plus 2. If we had 2 times 3, it would equal to 2 times 3 times, right? So this could be 2 plus 2 plus 2, or it could be 3 plus 3. Either way, for this, you'll get 6, and this one you'll also get 6. This one will get us 4, and we can see that if we go ahead and move those 4 spaces, so let's say it's 2, it means it's 2 times. So we go ahead and start 1, 2, which is going to be 1, 2, 1, 2, which means we move 2 times. So starting at here, 1, 2, 1, 2, right? And we get 4. So that's a little bit looking on there, but let's go ahead and do the same way we did it last time with our blocks. We can have some little geometric blocks. Or so we want to see how this represents 2 times 1, and we want to see how this represents 3 times 2. So you can go ahead and take a moment to think about that. Well, what we have here is we have this block repeating twice here, and this repeating once here, right? And so if we go ahead and fill this in, we have 1 block, and we have 2 blocks. So we now know that 2 times 1 is equal to 2. But we could already know that just by looking at this. And the same thing with this. We know that 3 times 2 is equal to 6. It's a very simple multiplication problem. But how do we know that this block represents that? So we have 2 and we have 3. Well, this is going to mean that these units are going to repeat 3 times in 2 rows. Or this row is going to repeat twice, or these columns are going to repeat 3 times because these columns represent 2, so this is going to be 2 times 3, and this is going to be 3 times 2, and either way we will get our answer of 6. And so that's how we know this. We can go ahead and of course count 1, 2, 3, 4, 5, 6, and so we know that is how we go ahead and tend to our multiplication. And some notes about multiplication. Multiplication is commutative. So if we have a number A times B, we can just write this as AB because that's the same thing as times. So let's go over some brief things with time. So let's say we have 3 times 4. Well, that's going to be the same as this, which is going to be this little dot, which will represent multiplication. We can't do 3 times 4 by just putting them next to each other, but we can do that with variables. But what we can do is we can use a parentheses to represent multiplication, so 3 times 4. And these all mean the same thing, so that's going to be 12, and 12, and 12. Right, we can go ahead and remove that. But this also means that A times B is equal to B times A, or AB is equal to BA. And this can apply for any number of these things. You can have A times B times C times D can be equal to C times B times A times D, because at the end of the day, you're going to have these all being multiplied in the same sort of fashion. So let's say we have an example of 3 times 6 times 4. Well, we can show, well, let's do 3 times 6 first. Let's bring that out. So 3 times 6, and then we'll do it times 4. So 3 times 6, it's going to be 18, and that's going to be times 4. Well, 8 times 4, that's going to be 32, and 1 times 4 plus 3 is going to be 72. And so what we can do is we can go ahead and move this around and say 6 times 4 first. So what we're doing is we're saying ABC is equal to CBA, or it's also equal to BCA. We can go ahead and write that in that way. So we do 6 times 4, which is going to result in 24, times 3. Well, 4 times 3 is going to be 12, 2 times 3 is going to be 6, and you add the 1 and you get 72. And so that's just an example proving that or it doesn't necessarily prove for all numbers, but you're just going to have to trust me on that one. You're going to show that that property is as such. And also, multiplication is distributive. So let's say we have some number A times B plus C. Let's go ahead and look at this with real numbers. And we want to know what this is going to be equal to. So let's go ahead and do this with real numbers. So let's say we have 4 times 6 plus 3, right? So what we go ahead and do is we have 2 ways of doing this. We could have done the order of operations way, where we would do 4, and we do 4 times some number, but we have to do the things in the parentheses first. So we'd look at 6 plus 3, that's going to be 9. That's going to be 9 times 4, which is 36. Or what we can do instead is we can go ahead and distribute this 4 to the 6 and distribute this 4 to the 3 in order to get 2 new parentheses here. And so what we get is we get 4 times 6 plus 4 times 3. Because what we're doing here is we're doing 4 times 6 and 4 times 3, and we're adding those things up. Because what we're doing here is we're essentially distributing. So we can do the same thing with our variables. So BC times this A of sorts. We do AB plus AC. And that is the exact same thing we have here, except we've added parentheses here so that we know this comes first. So we do 4 times 6, that's going to be 24, plus 4 times 3, that's going to be 12, 2 and 4, that's 6, 2 and 1, that's 3, we get 36. And that is the same as here, we can see. And so that's just an example with distribution and the distributive property of multiplication. A few other things. So any number, let's say A times 0, so A times 0 is going to be equal to what? Well, 0. Because if you have something repeating 0 times, you're going to have 0. So 2 times 0 is 0. 7 times 0 is 0. 100,000 times 0 is 0, right? And so that's a very, very easy concept to keep in your back pocket. Another concept that we can use is any number, let's say B times 1, will always equal B. So that just means it's going to repeat itself 1 time. So 8 times 1 is going to be 8. 72 times 1 is going to be 72. So any number times 1 is just going to be that number again. But this also means that we have an interesting property where we can remind ourselves that b is also equal to 1b. And we can remind ourselves that about that with a lot of numbers. So 8 is, remember, it's equal to 1 times 8. And so we can expand the notation. And when we talked about the distributive property of the number, so we have a times b plus c is equal to a b plus a c. This is interesting, which you will learn later. It is something called factoring. So this is the factored form of this. So when we distribute, we go ahead and turn it into this, and when we factor, we go ahead and turn it into this right here, Because what we can do is we can factor out this a. We can say, well, these numbers both have a, and so what I can do is I can go ahead and bring this a onto the outside, such that now we have a, and when I bring these b and the c inside of a parentheses, right, we have b plus c since we factored out our a, so we just imagine the a doesn't exist here and we're putting it outside, right? That's why we have the a here, and now we just have b plus c. And we can see that that factored form is the same as this here. So, yes, I'm going to introduce something called Vedic maths for multiplication to help speed multi-digit multiplication along. So let's say we have a multiple digit multiplication. I don't know if you remember how to do this, so we'll go ahead and go over it. So let's say we have 37 times 54. How do we do this problem? Well, the standard way is what we do is we do 7 times 4, which is going to get us 28, and we put the 2 up here, and then do 3 times 4. So what we're doing is we're distributing these numbers into the ones place. So 7 times 4, which is going to be 28, and we bring the tens out of this, and we move the tens to the tens place, and then do 3 times 4, which is going to be 12, and then we add this 2 to the tens, so we're going to get 14. And then we do 7 times 5, which is going to be 35, and we'll add this 3 up here. 3 times 5, which is going to be 15, 16, 17, 18. And we move, when we multiplied into this side, when we multiplied 7 times 5, we moved the number over by 1 place. Notice we didn't put any number right here, because we're not going to put a number right here, because what we're doing is we're multiplying into the tens place, so we're multiplying across. So that means all of our numbers will move diagonally, since we're multiplying in the tens spot. And so what that means is we essentially start at the tens spot. If we had 3 digits, when we would multiply the 3rd digit, that would go here. If we would have 4 digits and we multiply the 4 digits, that would go here, and so on and so forth, and it would go in a diagonal pattern. So what we do next is we go ahead and add up these numbers. We go ahead and say 8 plus 0 is going to be 8, 4 plus 5 is going to be 9, 1 plus 8 is going to be 9, and 1 plus 0 is going to be 1. So we get 1,988. So what is a quicker way to do this? First, I would go ahead and master this way so you can make sure that you're doing the right way. But what is a quicker way to do this? Well, let's say we use the same problem, 37 times 54. What we can do is we can multiply 7 times 4 and then bring out the tens into here. and immediately start to add it to 7 times 5 and 3 times 4. And then we go ahead and add all of this up, which will be 2 plus 2 will be 4. So what we'll get right here is we'll get 49. And so what we do is we put the 9 right here, and we move this 4, since it's in the tens place, into the next addition that we're going to do. And what we now do is we now do 3 times 5, and we multiply straight down. That's going to be 15. And we add that to our 4, which is going to be 19. And we add the whole thing right there, 1998. And so that's very nice and very simple, very quick way to go ahead and do that. And this works with 3-digit numbers as well. So let's say we have, I'm going to multiply 572 times 493. So what we're going to do is we're going to multiply here 2 times 3, which is going to be 6. Then we multiply 7 times 3, which is going to be 21. Go ahead and bring our 2 up here. Now we do 5 times 3, which is going to be 15, 16, 17. Now we go ahead and do our 2 times 9, which is 18. Bring this to the tens place. 7 times 9, which is going to be 63. Add that 1, we get 64. We're going to bring the 6 to the hundreds place now. And 5 times 9, which is going to be 45. So now we get 51 from that. Now we do 2 times 4, which is going to be 8. We do 7 times 4, which is 28. We bring our 2 up here. 5 times 4, which is 20, and we're going to add the 2. So we bring down our 6, then we add this, so 8, 9. We go ahead and add this, it's going to be 11 plus 8, it's going to be 9. And then we're going to add that right there, 1, 2, 3, that's going to be 21. Or that's going to be 11, I apologize. And 5 plus this plus 1, that's going to be 8. And right here, we just bring down our 2. So we get 281,996. So now let's go ahead and do this Vedic mathematics way, which hopefully proves to be a little bit faster to you. So we go ahead and do our 572 times 493. So what we start off is we start off the same way we did last time. So 2 times 3 is going to be 6. We do 2 times, we have nothing in the ones place, so we don't bring out our 1. Why we have 0 just because it's 6. So now we do 2 times 9, which is going to be 18, plus 7 times 3, which is going to be 21. So we get 39. And so we put our 9 here, and we bring out this 3 to be added to something else. So we do 3. We'll add our plus sign. And now what we do is we multiply the bottom outside times the top outside. So the bottom left times the top right. Then we multiply the top left times the bottom right. And then we multiply straight down. So what does that mean? We're multiplying 4 times 2, 5 times 3, and 7 times 9. And we're adding these all up together. So 5 times 3 is going to be 15. 4 times 2 is going to be 8. And 7 times 9 is going to be 63. Well, this is going to get us 89. And so what we do is we put 9 here, and we bring out our 8. So the 8 from here, because it's in this other place, we bring it out here. And now what we do is we do the same thing we did the first time, which we're going to do is 7 times 4 and 5 times 9. So 7 times 4, and we're going to add that to this, is going to be 28, plus 5 times 9, which is going to be 45. So we get 28 plus 8, which is going to be 36, and plus 45, so 3, this is going to be 7, that's going to be 81. So that's all going to be equal to 81. And so what we can do is we can go ahead and put our 1 right here and bring out our 8 for next time. And now that we've multiplied these across, now what we do is we multiply straight down and add that number. So 5 times 4 plus 8, which is 20, plus 8, which is 28. And since there's nowhere left to go, we put the whole number here, 28. And so we get 281,996, which is the same number we got over here. That means they are the same. And so using this way, if you get really good at it, you can multiply much faster and in a much more clean fashion, because you can do all of this in your head, of course. So you can just go ahead and multiply across looking at it, and you won't have to draw or scribble all across your paper. But of course, if you want to, and if that does help you, you can do the other way. There is no real right way to do it. I'm just giving you alternative ways of the sort. So that is basically it for multiplication. Next time we're going to do subtraction, then division, and we're going to move on from there. So thank you.